Today we're going to start talking about normal distribution. This unit comes into play when we're talking about lists of data. So if I'm given a list of data and I want to analyze it, we've already learned some key statistical vocabulary before. We've already learned mean, median, mode, and range. And these values help us distinguish specific relationships about our data. So when I collect data and I want to analyze it, the mean tells me the average, the median tells me the middle of my data, remember the mode tells you the data that repeats the most, and the range determines the maximum number minus subtracted to the smallest, the minimum value. These data values, they do help us distinguish specific characteristics. However, these values also, aren't very strong enough on what we want to do when we're trying to analyze data a little deeper. So when we're analyzing sets of data, our main focus is the mean. If you have a strong set of data, your mean and your median are actually the same, which would mean they would be in the middle. And we have two symbols to represent the mean. The two symbols, this symbol is called mu. I said it looks like a U with a tail. And the other symbol is X bar. Those symbols represent mean, and they do represent different means in a problem. In this class, you just need to be able to recognize that the symbols mean both mean. But if you were to take further statistics classes, you would realize that this one is what's called the population mean, and this one is called the sample mean. So the sample is like the survey you're collecting. So if I were to analyze all of my students' SOL scores, that would be a sample. But if I wanted to analyze the entire state of Virginia's SOL scores, that would be a population. And if you were to take other statistics classes, you would be able to see that those values are different. But in this class, like I said, you just need to know that they mean mean. So when we're analyzing data, we want to be able to determine how likely something is to occur again. The way we're able to do that is by looking how our data is spread out. Right now, we only know range, and range tells us our max value minus our min. So range tells us how spread out each value is. So if I have just a list of data, my range just tells me how far away is my biggest number from my smallest number. This doesn't really give us much information to determine how consistent our data is. So we want to use what's called standard deviation. Standard deviation is the average distance each data value is from the mean. So if I were to take each of these tick marks, which are my data values, if this is my mean right here, I want to find how far away each of these are from the mean, and then I want to take the average of it. That's what standard deviation is. There's a variable for standard deviation. The variable is what's called the lowercase sigma. It just, I always say, looks like an O with a hash. That's what sigma is. So standard deviation is pretty powerful because it can tell us more information about how spread out each of those values are. So if this value is 1, if this value I circled is the mean, I can say, okay, each data value is approximately 2 standard deviations, 2 units away. So when I'm looking at the following lists of data, I want to determine which one has most variability, which one is the most spread out. And you can't necessarily just tell by looking at the numbers, but you can tell by looking at the specific information. So you're able to actually type all of these data lists into Desmos, and it will calculate the mean, standard deviation. It will also even calculate the median. The range is usually pretty easy to do. But if you go ahead and you open up Desmos, if I want to type in a table, I'm going to press this plus sign, and I'm going to press table. And I got to go over here and look at it. It starts at 4 and goes to 16 counted by 2s. I'm going to type in all of my values, and Desmos is pretty sophisticated. It starts to project what you're doing. So 4, 6, 8, 10, 12, 14, 16. So once you type that data in, down at the bottom of your screen on Desmos, you have the keyboard. So you're going to click the keyboard, and then if you hit functions and you go to stats, you're going to see where it says mean. And then you have to tell Desmos what list you type your data into. Notice I type my list into X1, and I can actually change that list to anything I want, but I just don't change it. So how I get X1 is I type X, and then I press 1. And notice right here it tells me my mean is 10. If I wanted to calculate the standard deviation, how I'd calculate the standard deviation is I would go to functions, I would go to stats, and notice I have two different types of standard deviations. I have standard deviation and I have standard deviation P. We're going to focus on standard deviation P in this class. Remember I talked about there was being a little bit of a difference between a population and a sample data. But in this class, we focus on the population, which is standard deviation P. And if I type X1, it's going to tell me my standard deviation is 4. So I can actually go over to my table in my notes. And my mean was 10 for L1. My standard deviation was 4. Range is pretty easy because this is my max minus my min, so that's 12. If you couldn't figure out your median was the middle, you could even come back to Desmos, functions, median is right there, and type in X1. And again, my median is also 10. So I want you to pause this video, and I want you to do the rest, L2 and L3, and then I want you to unpause it and actually answer the questions below, and then unpause it, and I'll have the answers on the board. So if you notice, I have put the answers on the board, and none of them have the highest mean because they're all the same, and with the range and with the median. So notice that those values change. Those values didn't change. The only thing that changed was my standard deviation, which meant L3 had the most variability because it was the most spread out. Because my standard deviation is larger, it's more spread out, which is why I have more variability. So when we were analyzing data, we want to figure out how I can make predictions, how I can determine the probability, the likelihood of something happening. So how we pictorially do this is we use what's called a bell curve. A bell curve looks just like what it looks like. It's kind of like a hill, a mountaintop. It's a bell curve. It visually represents the mean and standard deviation. So how I label this is I always go straight down the middle, and that's my mean. And then I go 3 tick marks to the right, and I go 3 tick marks to the left. How I get to those tick marks is each of them are measured 1 standard deviation apart. So to get from the mean to my first tick mark, that's 1 standard deviation. To get from my mean to my second tick mark, that's 2 standard deviations. And to get from my mean to my third tick mark, that's 3 standard deviations. Now, if I wanted to go to the left 1 tick mark, that would be negative 1 standard deviation. If I wanted to go 2 tick marks to the left, that's negative 2 standard deviations. And if I wanted to go 3 tick marks, that would be negative 3 standard deviations. So if my standard deviation is greater than 0, that means it's above the mean. So all of these values here are above the mean, and all of these values down here are below the mean. That means it's less than 0. So in class, we did a Skittles example where you had to collect data from your classmates to get the data for this. I'm going to go ahead and I'm going to copy down the data. And if it's the wrong data, then just go with what I have. So with this data, I now want you to pause and I want you to type this into Desmos. And I want you to determine the mean and the standard deviation. So I want you to come in, I want you to find what mu equals and what sigma equals. So remember, if I go over to Desmos, if you still have old stuff on your screen, it might be wise to reload it so it goes away. To get your table, you hit plus button table, and then you're going to type all these values in. So go ahead and type all these values in, calculate the mean and standard deviation, and then we'll come back together. So I've gone ahead and I've typed in all of my data. If I want to show you how you get the mean, I'm going to press the keyboard in the bottom left corner. I'm going to press Functions, go to Stats, I'm going to press Mean, and then I have to tell Desmos where I typed my data. I typed my data into X1, so I'm going to press X1. And my mean, I'm going to round to the 10th. I'm going to do 48.6. So my mean is 48.6. Okay, and then to calculate my standard deviation, I'm going to go Functions. Remember, I want standard deviation P, and you type in X1. My standard deviation is 1.8, if it will let me write tonight. 1.8. Okay, so now if I go back over to my notes. So if we look at this, my standard deviation is 48.6 and my standard deviation is 1.8. So what that means is each of these values, each of these bags of Skittles, they're approximately 1.8 away from the mean. So now I want to be able to visually represent this on a standard deviation. So what does the standard deviation mean? Each bag of Skittles is about 1.8 pieces off from the average. Okay, so now I want to draw a bell curve. So I'm going to erase this, and we're going to make our mean, and we're going to round, because it's going to make our life 10,000 times easier. So we're going to make our mean and our standard deviation, we're going to round. So it's going to be, instead of, and of course I just erased it, and now my brain forgot, it was 48.5, so we're just going to round that to 49. And my standard deviation was 1.8, so I'm just going to round that to 2. And I'm just doing this to make my life a little nicer. So how do I make my bell curve? Down the middle is my mean, which is 49. I now go 3 tick marks to the right and 3 tick marks to the left. How I get to each tick mark is I just increase it by 1 standard deviation. So to get to this, I'm going to add my standard deviation, which is 2. So 49 plus 2 is 51. To get to 51, add 2 more, because that's my standard deviation, 53. And to add 2 more, that's 55. To work in the reverse direction, I'm just going to subtract my standard deviation each time. That's 47. And then another time is 45. And then the last time is 43. So what this bell curve is saying is I have basically a 100% or 99.7% chance that in a bag of Skittles, I'm going to have anywhere from 43 to 55 pieces. That's what this distribution creates. It's being able to determine that I have a specific chance of getting a specific amount of candy in my bag. That's what that is trying to mean. So another thing I want to mention, the further away you are from your mean, the less likely it will occur. So just about everybody got 49 pieces of candy. But if the further away, so like if I had 55 pieces of candy, that's very unlikely to happen. 58 pieces, now this bell curve technically does go on forever. So I could have like 60 pieces, but the chance 60 pieces is over here. The chances of getting 60 pieces of candy in a bag of Skittles is extremely unlikely. So the further away you are from the mean, the less likely it will occur. So let's go down and let's look at this next problem. So on this one, it says, I want to calculate how many standard deviations away from the mean is blank bag of Skittles. I'm actually going to undo my erasing, and I'm going to, let's see, maybe if I zoom out a little. There we go. All right, hold on one moment. So I just went ahead and redrew this so we can see it, and I filled in these questions because obviously every year these numbers are going to change. So it says, how many standard deviations away from the mean is a bag of 53 Skittles? So notice 53 Skittles is right here. Now, how many standard deviations away is that from the mean? So if I go to the mean, that's 1 standard deviation, 2 standard deviations away. So I would do 2 sigma. You can also write, if I don't write in pen, if I write not in highlighter, you can say it's 2 sigma above the mean, because if it's going to the right, it's above. How many standard deviations is 49 bags? I didn't want to say 49, I wanted to say 47. 47 bags is one standard deviation away, right? So I can say one standard deviation below, or I can just say -1 standard deviation. That way I know it's going below. How about 43 Skittles? 43 Skittles, how many standard deviations away is that? Well, that's 1, 2, 3. And you can think of standard deviations like units of measure, so inches, feet, meters. I'm going 1 step, 2 step, 3 steps away. 51 Skittles, that's one standard deviation, and I can say again, say above or below, or I can just denote them with positives and negatives. And then it says how many standard deviations away from the mean is 49? Well, 49 is the mean. So how many standard deviations away? Well, that's 0 standard deviations away. So hopefully you're okay with understanding that. But now, what would happen if I wanted to figure out, what about 52? What if I have 52 Skittles? How far away is that from the mean? Well, notice 52 doesn't fall perfectly on one of my standard deviations. It falls in the middle somewhere. So here's what I have to approximate. Approximately how far away? I want to guess that's approximately 1.5 standard deviations away, because it looks like it's in the middle between 51 and 53. So in math, we don't really like approximating, we like exact answers, and so how we get those exact answers is by what's called a z-score. A z-score is how I get my exact answer. There's a formula for z-score, and it looks like this. Z equals x minus mu over sigma. This is my mean, hopefully you knew that. This is my standard deviation. X is the value that I'm testing. That's my test value. So if I actually were to calculate how far away 52 Skittles are from the mean, I would do 52 minus 49 all over 2. And if I type that in my calculator, 52 minus 49 is 3, divided by 2, sure enough is 1.5. So my educated guess was correct. So now it wants me to calculate the z-score for 38 Skittles. So that's my test value. So I'm going to do z equals 38 minus my mean, which is 49, all over my standard deviation, which is 2. So 38 minus 49 divided by 2, that's negative 5.5 standard deviations. And because it's negative on my bell curve, does that mean it falls above my mean or below my mean? It means I fall below. 16 Skittles, z equals 16 minus 49 all over 2. I get negative, hold on, let's make sure I did this right. Yep, I get negative 16.5 standard deviations below. So if we really talk about real quick how unrealistic getting this amount of Skittles in a bag is, it's because these standard deviations are so far from the mean. Going negative 16 tick marks to the left, that's almost completely unlikely, because I just said, if you were listening, to get from anywhere from 3 tick marks to the left and 3 tick marks to the right, I have a 99.7% chance of my data falling within 3 standard deviations. So negative 16, I have like a 1 in a bajillion chance of that happening. But this is just how, again, you would calculate to determine exactly how far it is and how unrealistic or realistic getting that kind of value would be. So if we go ahead and we keep talking about distribution description, it says any normal distribution can be described completely by using only its mean and standard deviation. The formal way to describe a normal distribution, they like to use symbolic notations, is they will say x is approximately normal, and then in parentheses they'll put your mean and your standard deviation. So a lot of times problems like to write it out like this, mainly to kind of confuse you, but the first number is your mean and your second number is your standard deviation. So if I look at this, it says the distribution of women's height is approximately normal with a mean of 64.5 inches and a standard deviation of 2.5 inches. Write a distribution description. All right, so the distribution description is x is approximately normal with a mean of 64.5 and a standard deviation of 2.5. So now I want to draw my bell curve. So if I draw my bell curve, I draw a dotted line in the middle. That is always my mean. And then I go 3 tick marks to the right, 3 tick marks to the left. And to get to each tick mark, I'm going to add 2.5. So 64.5 plus 2.5 is 67. That was a little less terrible. 67 plus 2.5 is 69.5. 69.5 plus 2.5 is 72. And now if I work in the other direction and I subtract 2.5, 64.5 minus 2.5 is 62. 62 minus 2.5 is 59.5. And 59.5 minus 2.5 is 57. So now I want to go ahead and I'm going to answer these questions. What is the value 2 standard deviations above the mean? That would be 69.5 because I just want 1, 2. What is 1 standard deviation below the mean? That's 62. And it says calculate the distance 70 is from the mean. So when it says I want to find how far something is from the mean, that means z-score. So I'm going to do z equals x, which is 70, minus my mean, which is 64.5, all over my standard deviation, which is 2.5. I'm going to type that in my calculator, and I get 2.2, which means it's about 2.2. It's like right there. It's above my mean. So I want you to go ahead, and I want you to do number 2 on the next page, and then I want you to be done, and we will continue next class.